The definition of a linear approximation is given here. Suppose that function f(x) is differentiable on the open interval I, which contains the point A. Then for x in the open interval, f(x) can be approximated by the following formula. That is, f(x) can be approximated by Lx, where Lx is the function of the straight line, and the formula is given by f of a plus f prime of a times x minus a. So here, when we do the linear approximation, we said when we choose a, or the A has to satisfy the following conditions. One is A is close to the point x at which we wanna estimate the function value, and it's easy for us to know what is the function value at A, and it's easy for us to know what is the derivative value at A. Like the previous example, we want to estimate the square root of 9.1. So 9.1 is x, and we choose A to be 9 because 9 is close to 9.1, and the function value and the derivative value at 9 is we know what they are. Okay. Now next, try another problem. Use a linear approximation to estimate cosine 3/6. So here, the point is 3/6. We want to estimate the function value at this point, and here the function f(x) is a cosine of x. We want to estimate f of 3/6. Okay. So the first thing we want to do is to determine which point shall we choose as A. So we need to think about which number is close to 3/6, and also we know what is the function value, what is the cosine of that number. So that number could be pi/6, because pi is close to 3, therefore pi/6 is close to 3/6. And also we know what does f of a, we know what does f of a equal, because f of a equals cosine of pi/6. This is a value we are asked to remember when we study trigonometry. This equals the square root of 3/2. Okay. Next, we need to find the derivative at A, the derivative of function when x equals A. The derivative of this function gonna be negative sine x. Therefore, f prime of A equals sine equals negative sine of pi/6. Which equals negative 1 over 2. Okay, so we know this term, and we know this term, and we know A. So we can set up the equation of Lx, which is square root of 3 over 2 plus negative 1 over 2 times x minus pi over 6. And to approximate cosine of 3 over 6, we substitute 3 over 6 for x into L. That is square root of 3 over 2 minus 1 over 2 times 3 minus pi over 6. Plus 4. And then to combine these two numbers, I multiply the first number, I multiply the denominator and numerator of the first number by 6. So pi plus 6 times the square root of 3 minus 3 over 12 will be used to approximate the cosine 3 over 6. Let's take a look at this graph. So here we have the graph of function fx equals cosine x, and we want to approximate the function value when x equals 3 over 6. So the actual result is about this 0.8776. Okay. Now use linear approximation. We first find this point A and f of A. Which is the blue point. And at the blue point, we draw a tangent line. And the equation is this. The equation is this. Lx equals this. And minus 1 over 2 times x pi over 6. And then next, we evaluate the the function value L of 3 over 6. That will give us the approximation. Okay. Let's choose a different kind of So this red one is the graph of the straight line, and this green one is the graph of our function, and the orange point is our approximation, and the purple point is the actual result. So you can see they are pretty close. Right? The difference is pretty small. So pi plus 6 times the square root of 3 minus 3 over 12 is around 0.8778. So cosine So cosine 3 over pi is around this.